Today we're going to be talking about empirical formula. Empirical formula is a formula that gives the simplest whole number ratio of atoms in a compound. There are 4 steps on figuring the empirical formula, and we're going to be talking about those today. First step for determining an empirical formula is start with the number of grams of each element. That will be given in the problem. Second step, convert the mass of each element to moles using the molar mass from the periodic table. Third step, divide each mole value by the smallest number of moles calculated. Fourth step, round to the nearest whole number. This is the mole ratio of the element and is represented by subscripts in the empirical formula. A compound was analyzed and found to contain 13 grams of Ca, 10.8 grams of O, and 0.675 grams of H. What is the empirical formula? We're going to follow these 4 steps that were given before. First step is take what is given to you in the problems. Now that we have these 3 here, we're going to put them in. We have to find their periodic table. We have to go to our periodic table and find out what their atomic mass is. Now that we did that, let's go over here. We have to. So now we're going to cancel grams of Ca on both, grams of O, and grams of H. So now all we need to do is 13.5 times 1, which is just 13.5, and divided by 40.1. And that's going to get us 0.337 moles of Ca. And same thing right here. 10.8 times 1, which is just 10.8, divided by 16. And that's going to get us 0.675 moles of O. Same thing right here. And that's going to get us 0.668 moles of H. Now we're going to divide by the smallest number. And the smallest number is 0.337. And that's going to get us mole Ca equals 1. And that's going to get us mole of O is going to be 2. And this is going to be mole of H, which is 1.98, but we're just going to round it up to 2. So the final answer is going to be CaO2 H2. But since we can simplify that, the real answer is going to be CaOH parentheses 2. The Ca we got from right here, Ca is 1, so you only need to put 1, but we don't really need to put the 1. The mole O is 2, so we have to put the 2 right there. The H is 1.98, which we just rounded to 2, and we have to put the 2 right there. Today we made a homemade smoke bomb. We used a large mixing bowl, skillet, sugar, potassium nitrate, empty toilet paper roll, cardboard, masking tape, scissors, and face tissue. First we started off by getting the toilet paper roll and the cardboard, and we put the cardboard underneath the toilet paper roll and taped it down securely. Then we put sugar inside the bowl and potassium nitrate also. We put 3 amounts of potassium nitrate and 2 amounts of sugar. We stirred it really well, and then we put half a cup aside of the potassium nitrate and sugar aside so that we can make a spark. Then we cut the toilet paper roll and folded it so that we could put the potassium nitrate and sugar in it, the one that we put aside originally, so that it would make a spark. Then we folded the sides together and secured it. After that, we put the potassium nitrate and sugar from the skillet inside a skillet, another skillet, to let it heat up. We put it on high, and we had to stir really well. After stirring really well, it started making a different type of material, a peanut butter type material. Then we put it inside the cardboard, inside the toilet paper roll, really carefully because it was really hot, and we had to secure it inside and fill it up. Then we had to put the lighter inside it, and then we lit it. We went outside and we lit it on fire, and that's what we got from this experiment. What is a smoke bomb? They're made of sugar and potassium nitrate. That's it. They're pretty safe, but the sugar could eventually get you diabetic, but don't eat the potassium nitrate. The only real danger of potassium nitrate is that it is an oxidizer. It will technically add fuel to the fire, but it's not explosive or flammable by itself. None of the compounds produced at all are dangerous. The smoke you are seeing is due to a combination of water vapor and potassium carbonate particles rising in the air. Just like any smoke, you shouldn't breathe it in, but it is highly unlikely to do you any harm.